Alrighty, so in this video we're going to start Unit 5. Over the last several units, since the beginning of the year, we've been talking about this idea of congruency, congruent figures, congruent segments, congruent angles, and we know that congruent means exact same. Now we're going to be talking about similar figures. Now, similar polygons are figures with the same shape. So it's the same shape, but now there's going to be different sizes. So they're not congruent anymore. They're either blown up or they're shrunk down. So there's a change in size. And the criteria involved is that you have congruent angles. So all of the angles need to be congruent. And this next part is new. This next part is that all the sides must be proportional. So proportional sides. And those proportional sides must all match. And when they match, that's going to be called the linear scale factor. And that linear scale factor is a ratio of the lengths of corresponding sides. So remember, a proportion is a bunch of fractions. So for example, proportion could be like 1/2 equal to 2/4 equal to 4/8 equal to 8/16, something like that. All of those ratios, all of those fractions simplify to 1/2 and are equal. So the same thing has to match up between the sides in similar figures. Now, we've had congruency statements, and there is a bunch of stuff that matched up in congruency statements. The same idea is here with the similarity statement. So you'll see down in the example 1, it says, in the diagram, triangle ABC is similar to triangle DEF. So this figure right here, that symbol means similar. Okay, and so all those corresponding parts still match up in your similarity statement. So the congruent angles, angle A needs to be congruent to angle D, angle B needs to be congruent to angle E, and angle C needs to be congruent to angle F. So you'll notice in example 1, we have these two similar triangles. DEF is an enlargement. It's gotten bigger compared to ABC. So now in number 2 here, what I need to do is check that the ratios of the corresponding side lengths are equal. And so ratio 1, let's say AB, well, AB needs to match up with DE. And if I do that, AB is 10, DE is 15. So if I simplify that, 10 over 15, that's going to simplify to give me 2/3. Next, I'm going to do the same thing with ratio 2. So I'm going to say, let's do BC, and BC is going to correspond to EF in my similarity statement. BC is 8. EF is 12. 8 over 12 also simplifies to 2/3. And then last but not least, let's check out ratio 3. What side lengths have we not done yet? We haven't done AC over DF. So AC is 12. DF is 18. If I simplify that fraction, I'm going to get 2/3. So you'll notice that all of my ratios are equal to each other. So these side lengths are in proportion, because when I compare the side lengths of ABC to the side lengths of DEF, they all equal 2/3. So my linear scale factor is 2/3, which means that triangle ABC is 2/3 of the size of triangle DEF. So you may notice that right here, let me change one thing. Right here it says triangle, oh, I covered it up, sorry. It said like triangle ABC, you want to find the linear scale factor from ABC to triangle DEF. Well, that means that ABC is on top, and DEF is on the bottom. Okay? And so if it said, like if I do a little tangent here, if it said, what's the linear scale factor from DEF to ABC, I would put DEF on top and ABC on the bottom. Okay? So that's important to remember, this whole idea of where you're starting and where you're ending. So that's the whole idea of similar figures, using your similarity statement, matching up congruent angles, and then matching up corresponding sides to show they're all proportional. Okay, this part up here is super key. Similar figures have congruent angles and proportional sides. So that's what we'll be doing a lot of. We'll be setting up proportions and solving those. So another concept is the perimeters of similar polygons. We haven't really talked about perimeter much this year, but remember, perimeter of an object is just adding up all the sides. And so if you add up all the sides and get that number, that's still a one-dimensional number. Perimeter is still one-dimensional. So if the two polygons are similar, the ratio of their proportions has to equal the ratio of their corresponding side lengths. So if this example, if I have these two similar quadrilaterals, then their perimeters are going to equal each of these corresponding side length ratios. So, nope, not equals. Sorry about that. So the perimeter is going to equal KL compared to PQ, LM compared to QR, MN compared to RS, and NK compared to SP. Okay, so all of those ratios are going to be equal to each other, and it's going to be the same as if you compare the perimeters between the two objects. All right, so what would that look like in a problem? Example 2. In this diagram, this five-sided figure ABCDE is similar to the five-sided figure FGHJK. So if I want to find the scale factor of FGHJK to ABCDE, what we need to do is match up corresponding side lengths with this first, with the big figure first. So this is going to be first, and that's going to be on the bottom. Okay? So let's see what matches up. I've got FG, which is 15, matching up. So FG matches up with AB. So I'm going to put 15 on top. I'm going to put the 10 on the bottom. And if I simplify that ratio, I'm going to get 3/2. So the linear scale factor is equal to 3/2. All right, so now how can I use that to find the value of x? So I know the ratio of the corresponding side lengths has to be 3/2. So I'm going to start with a ratio that I know. Okay, and then the top belongs to FGHJK. On the bottom, that 2 belongs to ABCDE. So if I want to solve for x right now is AE, which belongs to my second figure. So that x is going to go on the bottom because it belongs to ABCDE. And then its corresponding part over in the other figure is 18. So 18 is going to go on top. And so try to think back to last year. How would you solve something that looks like this? You would cross multiply. All right, if I cross multiply, I'm going to take 3 times x, which is 3x. Then I got my equal sign. And then I've got 2 times 18, which is going to give me 36. And then I divide both sides by 3. I'm going to get x equals 12. So x, remember, is also AE. So AE is equal to 12. Okay? The next question is asking us to find the perimeter of this figure ABCDE. So remember from the last slide that the ratio of the perimeter has to equal that linear scale factor. So I know the linear scale factor is 3/2, with the top belonging to FGHJK, the bottom belonging to ABCDE. Okay, so now what I need to do is I am going to find the perimeter of FGHJK, and I'm going to compare that to the perimeter of ABCDE, which I don't know. That's my x. I'm actually going to use a different variable since in the problem above we solved for x. All right, but if you'll notice, you know all the side lengths of FGHJK. So I can find the perimeter of that object. I'm going to do that. 18 plus 15 plus 9 plus 12 plus 15. All right, and so if I want to set up this proportion, I've got my linear scale factor equal to the perimeter of FGHJK, which I just found as 69, and then that's going to be over my variable of y. Then I'm going to cross multiply, so I get 3y equals 2 times 69, which is 138. When I divide by 3, y is going to give me 46. So the perimeter of ABCDE is 46 units. All right, so a lot of setting up proportions and cross multiplying in this unit. Okay, let's do one more problem and then I'll let you guys try some on your own. In number 2, the lengths of the sides of a triangle have the ratio of 2 to 5 to 7. If the perimeter is 84, what is the length of the biggest side? So in something like this, 2 to 5 to 7, if sometimes I find it helpful to draw a triangle. Like if these side lengths are 2 to 5 to 7, that's not what the actual side lengths are. That's just the ratio of them. Okay, but if they're in that ratio, then the perimeter of this ratio triangle is going to be 2 plus 5 plus 7. All right, so that's 14. So if I set up a ratio, because I'm trying to find the length of the biggest side, like the actual length of the biggest side. Well, the biggest side in my ratio triangle is 7. So what I'm going to do is I'm going to compare 7 to 14. And what that is that's the length of the biggest side compared to on the bottom, which is the perimeter. So if I know my actual triangle has a perimeter of 84, I can put that on the bottom so that it matches those corresponding parts. So like the perimeter is on the bottom and the length of the biggest side is on top. So since that's what I'm trying to solve for, I'm going to call that x. And then when I cross multiply, I'm going to get 14 times x, which is 14x, equals 84 times 7, which gives me 588. And when I divide that by 14, x is going to equal 42. So the longest side, so this is the longest side, is 42. Okay, so that's going to wrap up this video. I have these You Try Now questions. I've got 4 of them for you to try. The answers are on the bottom of your sheet of paper. I will also throw my worked out answers on these as well. But give them a try first. Try to see if you can do it, and then check your answers. All right, so there's my worked out for the You Try Nows. Make sure that matches your work. There are a couple different ways that you could set up your ratios. Just remember when you're setting up a proportion, like if I look at number 2, if you look across, the tops have to have the same like category. They have to be relating to the same thing, and the denominators have to be relating to the same thing. So like in number 2, the top here, the x and the 12, those are corresponding parts. That's saying EF matching up with BC. No, I'm sorry. Ignore that. All right, so like I was saying, sorry, that the tops, like that X and the 12, those both belong to triangle DEF. So like the tops here are triangle DEF. They both belong there. And then on the bottom are their corresponding parts in triangle ABC. So think back to algebra when you were setting up those proportions, how those tops have to match and the bottoms have to match. But if you set it up differently, you could also set it up as x over 12 equals 6 over 18. It's going to work the same there as long as you're showing your work. So there's the first two. Pause it to make sure your work matches. If you have any questions, jot them down. And then here are the other two you try nows. So in the number 3, you're setting up corresponding parts using your similarity statement. So like ST matches up with FE, so that's why I have 5x plus 2 over 2. And then on top, since these are all belonging to triangle STU, and on the bottom, these are all belonging to triangle FED. So that's how I set up that proportion. So if you have any questions, just make sure to jot it down. Make sure you get the notes. We'll recap it next time I see you in class.